Okay. And then this is, okay, so we use Fleming's left hand rule, okay, to determine the direction. Yeah, so very easy, but don't forget to label the question, the label the direction. So for this one, dia bagi dah, the question wants you label F, so you write F here, this direction. How do you get this direction? You use Fleming's left hand rule. Okay, next, explain how the force is produced. Okay, ingat tadi balik. The force is produced first tadi, the force tu first kita ada permanent magnet. Okay, permanent magnet ada its own magnetic field, and then we have temporary magnet. How do we get temporary magnet? So this is when we have a conductor, and then that conductor ada current flowing. Okay, and then both of the magnetic fields interaction of the two magnetic fields. So that's the answer. Jadi this one you have to understand, and then you write in complete sentence. When current passes through a copper wire, so we are talking about conductor wire, then ada current, so that's when we get temporary magnet. So other name of temporary magnet is electromagnet. Then the interaction between electromagnet field, the temporary magnet, and the permanent magnet, this one, produces a force. Okay, so that's easy. Okay, very easy. Faham kan? Then you boleh jawab. Macam mana pun dia pusing soalan, you should be able to answer. Okay, yang ni, question ni, the modification, another application question. So diagram 5.2 shows a simple electric motor modify. So what can be done so that the electrical motor able to function effectively? Okay, so this one cannot be the answer. Function effectively ni tak boleh jadi your reason. Cannot, haram. Okay. Now, first factor, thickness of coil. So kita tahu ni coil ni. Okay, the thicker the wire, the better. Kenapa? So kita tahulah, topik elektrik kita dah belajar. The thicker the wire, the less the resistance. So that means the current increase. So you can answer either one. Sama ada you nak cakap less resistance, or you want to say increase current. Dua-dua betul. Okay, so dapat 2 marks. Okay, 1 mark, 2 marks. And then the shape of magnet, usually kita akan use, kita mesti akan improve so that kita guna U-shaped magnet. So how is U-shaped magnet? So ini bentuk segi empat macam ni. Kita nak improvise, kita guna radial shape ataupun ni C-shape, ataupun U-shape pun boleh lah. Dia bentuk U pun ada, bentuk C pun boleh kita panggil, ataupun curve. Why? So you can boleh ingat terus lah jawapan ni. Ini mesti jawapan untuk radial shape ni. U-shape ni mesti untuk dapatkan radial, produce radial magnetic field. Okay, we move on to 4.2. 4.2. Okay, jadi so kita dah buat 2 kali session. Okay, untuk force on a current carrying conductor. And then we use Fleming's left hand rule. Okay, sometimes kita ada guna sikit lah another rule, which is the right hand grip rule ni. And then you tahu dot, cross, dot ataupun cross ni into the out of page, into the page. Ini current out of page. Okay, now kita nak move on to the next subtopic, which is electromagnetic induction. Okay, untuk this topic you just need to understand this one. Okay, dalam electromagnetic induction, how do we get induced current? So first, we must have something that is moving. So mesti ada relative motion. That's number 1. Bila ada relative motion, bila kita ada relative motion, number 2, then there is cutting of magnetic field lines. Yeah. So sometimes we talk about cutting of magnetic field lines. So it's similar to change of magnetic field flux. So that means when there is cutting of magnetic field line, that means we are changing the magnetic flux. Then what happened? So that is when current is induced ataupun EMF is induced. Alright? So soalan dia mesti sama ada dia tanya daripada you akan explain ataupun you boleh fikir daripada relative motion to cutting, from cutting to dapatlah result ni. Ataupun sometimes soalan dia daripada dia kata current is induced, explain how. Jadi awak cakap lah, because of there is cutting of magnetic flux. Cutting of magnetic flux ataupun change of magnetic flux be due to either motion this way. Macam tu lah. So ingat ni sahaja. Ini je. Right. Now, dalam this topic, we also have 2 laws. Which first law is Faraday's law. Faraday's law, talking about rate of cutting of magnetic field lines. What are the factors? So first, number of coils. 2, speed. Speed of motion ni. Kadang-kadang speed of motion ni boleh ditentukan juga by the height. Jadi kan, any object that is fall down, kalau object tu from here, dia akan jatuh due to acceleration, gravitational acceleration ataupun gravitational pull, betul? If the objects further ataupun higher position, it will increase. Dia punya velocity kat sini will be higher because of the acceleration. But if the object down here, kat bawah ni, speed dia akan jadi lower. Jadi in order to get higher speed, sometimes we talk about the height. You put the object higher. So that's number 1, number 2. And then the third one is the strength of magnet. Right, so that's about rate of cutting of magnetic field lines, Faraday's law. When do you use Lenz's law? So Lenz's law is used to determine the direction. Kita nak tahu the direction of induced current. Ataupun now, how do you use Lenz's law? Jadi senang lah. Lenz's law states that, ini when bila kita guna. But what is it? Dia punya definition ataupun dia punya law lah. It says that Lenz's law states that the direction of induced current is such a way, always oppose the change producing it. Apa tu? Maksudnya macam ni lah. Kita tengok contoh nanti. So let's say this is selalunya you use Lenz's law untuk kita nak guna untuk this one is used for coil. Coil. Jadi bila nak buat example pun, kita ada permanent magnet north south. And then kita ada coil. Coil tu connected to galvanometer. And you should know galvanometer, the pointer starts at 0. 0 tu dekat tengah-tengah. At the middle. Now, so let's say dia boleh ada, first ada motion. Jadi kalau macam ni, nothing is in motion, so there is no induced current produced. So it's either kita movekan let's say kita buat first example, kita move the conductor. Now before that, kita tahu the permanent magnet. And then we know that permanent magnet always it's a permanent, so mesti ada magnetic field. Tebal sangat lah. Okay, direction north to south, 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 to south, to south, to south. Okay, jadi now if I move kita tak nampak tau the lines tu, with naked eyes. Tapi if I move the conductor, the permanent magnet into the coil, so you see, nampak tak macam the coil tu memotong, cutting the magnetic field lines, cutting the orange lines tu, nampak tak? Itulah cutting tu. So maksudnya awal-awal dia macam ni, but when it's in motion, ada changes happen. Apa changesnya? Cutting. Itulah. Alright. So if let's say the question says permanent magnet into the coil this way, so into the coil, so dia macam ni. Right. Tadi kita belajar when we have conductor. Okay, ni cerita lain Katalah tadi kita recall balik subtopic 1. When we have a conductor, okay, atau when we have a coil like this, okay, current flow. Okay, ni current. Okay, kita guna right hand grip rule. Okay, our thumb pointing this. Kan? Salah. Bila guna right hand grip rule, anak panah ke atas. Excuse me. Aduh. Anak panah ke atas macam ni. Okay. So, okay, grip your hand, thumb dekat sini, betul tak? Okay, other fingers tu semua anak panah ke atas, just like this. Kan? So, your thumb tu pointing this way, so maksudnya menunjukkan current this way. North this way. This is a coil. So, this is a coil, jadi sini north. Jadi, bila that's north, ini arah current. Yang ni current, arah current. Macam tu lah. Ni ke bawah, tu arah current. Okay, north dekat situ. So, remove ni semua. Okay. So, kita tahu kat sini, current this way. North is here. So, bila north dekat sini, what happen? Okay. If I have another permanent magnet, sini north. So, if north and north, what happen? They will repel. Repel poles, same poles repel. Tapi kalau kat sini adalah south, they will attract. Semua orang tahu benda tu. Boleh? Alright? So, same pole, repel. Different poles, attract. So, with this one, so, kalau kat sini direction into, maksudnya dia seolah-olah attract. Betul? Tapi, Lenz's law states that the direction is always opposed the change producing it. Jadi, dia macam seolah-olah attract. Okay, dia attract. Jadi, kita nak oppose. Bila oppose, maksudnya dia repel. So, kat sini kita buatlah. Sepatutnya dia attract, tapi dia repel. So bila nak repel, maksudnya if this is south, in order to repel, sini mesti apa? Sini akan jadi south juga. Jadi, so dapatlah south situ. So where is the direction of induced current? Direction of induced current ni south kan? Jadi, kalau guna right hand grip rule, thumb sini. So your other fingers, sebabkan sini arah north. Jadi kita dah tahu dah south is this way. Dekat belakang ni south. Jadi kita letaklah your thumb dekat depan. Jadi your other fingers tu ni arah apa? Current. Jadi current kita yang belah sini ke bawah. So bila current tu ke bawah, maksudnya your current this way. So deflection of galvanometer, galvanometer dia akan opposite to the direction of current. If current this way, deflection of galvanometer tu dia terbalik, dia this way. Ya? Macam tu. Boleh? Alright, so situ dulu for today. Kita tengok soalan satu lah nanti. The deflection of the pointer of the galvanometer increases when. Okay, ni tanya factors lah. Okay, bila tanya factors ni, kita dah tahu dah. Ni rate tau. Kita guna Faraday's law. Okay, the answer is D. Tadi we have mentioned about the factors tu. Speed. So, speed tu in terms of height. That's why kita jawab D. Higher position. Okay, number 2. Okay, diagram 2 below shows a copper rod that can be moved in 4 different directions between the poles of a permanent magnet. Which directions will produce a deflection of the galvanometer? Jadi maksudnya kalau galvanometer tu nak terhasil, kita kena dapatkanlah induced current tu. Okay. W and Y. Boleh tak? Jawapan dia A lah. Sebab direction dia mesti perpendicular. W dengan X tu, W tu boleh, X tak boleh. Sebab dia tak perpendicular to the magnetic field punya lines tu. Okay, and C, X dengan Z, dua-dua tak perpendicular. X dengan Z tu parallel. Okay, jadi Y dengan Z. So jawapan dia A. Diagram 3 shows a right hand which represent Fleming's right hand rule. X represent the jari yang tengah-tengah, middle finger. Middle finger menunjukkan current. C center, middle finger center. Number 4, diagram below shows a coil in a magnetic field. When the coil is part of a DC motor, what must be connected directly to X and Y? Jadi kita nak, ni dia, okay, DC motor. Dia punya keyword dia DC motor. Okay, so kita guna split ring. Split ring. What is split ring? Split ring is the commutator. Ring ni split up. Okay. Number 5. Diagram 5 below shows a bar magnet being pushed into a solenoid. Okay, tengok. So, ni kita buat apa? Okay, this is the change produced. Okay. Now, dia seolah-olah tu. But Lenz's law states that oppose to the change. Jadi, due to the Lenz's law, dia nak against the motion tu. Dia repel. So, repel means sini north. Sini must be north juga in order to repel. Okay. So, bila sini north, so, jawapan X akan jadi south. Mana? Okay. and Y jadi north. So number 5. Push into a solenoid. North, north. So jawapan dia ialah
Mama, dah gelap.
north and north.
Mama dah gelap.
So 5C ya.
Mama dah gelap. Dah
Okay.
gelap.
Sebab dia nak repel. Okay. Diagram 6 shows a bar magnet moves towards a solenoid. The pointer of the galvanometer deflects to the left. Okay, ini jawapan bagi. Alright. Which of the following pairs of poles is correct? Jadi kita tengoklah. So bar magnet ni. Okay, sekarang ni okay, this is what given changes. Tapi Lenz's law kata Lenz's law kata dia opposite. Bila opposite, jadi kat sini mesti repel. In order to repel, okay, ni sini repel. Repel jadi kat sini mesti sama ada north, north ataupun south, south. So, sama ada P north X south, tak boleh. P south X south, boleh. North, north. Sorry. Lagi satu kat sini, sorry kita tengok. Okay, so that's the first. Dia sama ada north, north ataupun south, south. But soalan ni dia dah bagi gambar ni. Ni, direction of current. Okay, that's the galvanometer pointer. Right? Jadi bila direction of current that way, sini kita gunakan right hand grip rule. So ini possibility. Number 3 kita tentukan dengan right hand grip rule. So thumb dekat thumb always menunjukkan direction of north. Jadi our other fingers, 4 fingers tu 4 fingers tu menunjukkan arah current. Sekarang kita dah tahu arah current. Oops. Kan arah current macam tu kan. So sini north. Kan? Jadi jawapan dia north, north. So south, south tak boleh terima lah. So bukan B. But number 5, number 6, the answer is C. Faham kenapa? Nampak ni south, south, north, north. Tapi yang menentukan sekarang sebab soalan ni dia bagi dah direction. Jadi kita tahulah it's not south. Okay, kita stop dulu sini.